Hello everyone, welcome to my YouTube channel Easy Way to Learn. I am Shelija and today we are going to discuss properties of ethanol and ethanoic acid. These two carbon compounds are of immense importance and they have great industrial use. So let's get started. See, the properties of ethanol. Firstly, ethanol is liquid at room temperature. The properties of ethanol. Ethanol is liquid at room temperature and its melting point and boiling point are as follows. Melting point is 156 Kelvin or minus 114 degrees Celsius and boiling point is 351 Kelvin or 78 degree Celsius. It is better to remember in degree Celsius. You can easily convert into Kelvin by adding 273. So these are in degree centigrade. You can easily remember. You can remember that boiling point of water is 100 and as compared to water the boiling point of alcohol is or ethanol is 70, lower than water. So by comparing the two you can easily remember. So ethanol is commonly called alcohol and is active ingredient of all alcoholic drinks. So the alcohol which persons consume is basically ethanol. So the drinking alcohol is basically ethanol. Formula, you must be familiar with the formula by now. So ethanol is C2H5OH and its structure, if its structure is asked, put OH here and rest of the bonds completed with hydrogen. So it is nothing but CH3, CH2, OH. Okay. And it has one more importance that it is used in medicines. So it is used as tincture iodine and because iodine dissolves in alcohol and it is also active ingredient of most of the cough syrups. Drinking alcohol basically it affects our nervous system and it slows down the response. So it has the consumption of a small quantities of dilute alcohol causes drunkenness and that is why it is advised not to drink and drive. See, even though this practice is condemned, it is socially widespread practice. However, intake of even a small quantity of pure ethanol can be lethal. Pure ethanol is called absolute alcohol. So, absolute alcohol means pure alcohol. Okay. Now we'll see chemical reactions of ethanol. Okay, one more thing. Methanol is poisonous. So you must remember methanol, that is CH3OH, is poisonous. A small quantity of this can cause death. So sometimes ethanol is mixed with methanol. So C2H5 ethanol is mixed with this methanol to denature it so that nobody consumes it. So it is called denatured alcohol. So if they are mixed, it is not it is basically for various other purposes and not for drinking. Sometimes some dye or color is also added to ethanol so that it is not fit to consume. So it is called denatured alcohol. Okay. Now we'll see chemical properties of alcohol or ethanol. So the first is reaction of ethanol with sodium. See, how you are going to remember this reaction and what does this reaction basically suggest? See, C2H5OH when reacted with small amount of sodium. So in beaker you will take ethanol and add small pieces of sodium metal. So hydrogen gas will be liberated. You can see vigorous bubbling in the beaker, and the compound that is left is sodium ethoxide, C2H5ONA. This is sodium ethoxide. So two molecules of ethanol react with sodium to form sodium ethoxide. See? So here also we'll put 2. See, let's balance it. Now it is balanced. So the easy way to remember is that you can practice writing it in this way. C2H5OH. Write two molecules of this C2H5OH and remove these two hydrogen atom. These will form hydrogen gas. This one. And sodium will combine with, here also you have to put 2. 2 molecules of sodium will give C2H5ONA and C2H5ONA plus hydrogen. So this is the way you can remember that 2 molecules of alcohol combining with 2 molecules of sodium to give 2 molecules of sodium ethoxide, and these two hydrogen atoms combine to form hydrogen gas. So this reaction also suggests acidic nature of ethanol. So metals are generally strong base. So sodium acts as a strong base and this will act as a weak acid. So in presence of a strong base, alcohol behaves as a weak acid and hence this reaction. Okay, this reaction is also used as a test for ethanol. And you already know that hydrogen gas, you can test hydrogen gas, bring a burning splinter near the test tube or the beaker in which you are performing and it burns with pop sound. So this reaction is also used as a test for hydrogen gas. Sorry, test for ethanol. Ethanol. That the given organic compound is ethanol. How you are going to test it? Add little bit of small pieces of sodium metal and you will start observing small bubbles rising. Bring the burning splinter or candle near the test tube. It burns with pop sound. The gas burns with pop sound. So the gas evolved is hydrogen and the compound that is given to you is ethanol. So make a point somewhere in your notebook or your notes and write this. This is a test for alcohol or ethanol. Okay. Next reaction is with concentrated sulfuric acid. See, concentrated sulfuric acid acts as a dehydrating agent. Dehydrating means it will remove water molecule. So let's see how the reaction takes place and how you are going to write it in a way that you can also remember it. See, ethanol, CH3, CH2, OH. Write alcohol in this way, CH3, CH2, OH. When it is treated with concentrated sulfuric acid, H2SO4 at 443 degrees Celsius. See, temperature is also mentioned, 443 Kelvin, not degree Celsius, 443 Kelvin. Okay. So what happens? Concentrated sulfuric acid is acting as a dehydrating agent. It will remove water from the compound. So see, water is removed here. So minus H2O. And what do you get? CH. See, you write CH and CH. Now observe, is the tetravalency of carbon complete? No. So we will simply put a double bond here. Now the tetravalency of carbon is complete. So this is the manner in which you remember. And what do you get? Ethene. So if the question is asked how you are going to convert ethanol into ethene or alcohol into an unsaturated compound. So this is the reaction. So this is a dehydration reaction which converts ethanol or alcohol, see, ethanol to ethene. In the similar manner, you can take any alcohol and can convert into corresponding alkene. See, let's take another alcohol. This is not part of the syllabus, but it might be asked. So you must be prepared how to write. See, if we take another alcohol like propanol. So writing the equation will be similar. See, put all the H. This is propanol. Now what you are going to do, when it is treated with concentrated sulfuric acid, minus H2O will remove water from here, H2O. See, hydrogen next to the hydrogen on the carbon next to the OH. See, this carbon is holding OH and this carbon having hydrogen. You remove hydrogen and OH from adjacent carbons. See, this hydrogen adjacent to this carbon. See, now what you get? See, CH3, C. Here you will put double bond and you get CH2. And here, so propene. So it is CH3, CH, double bond, CH2. This is the easy way to remember. Okay. Why you are getting here double bond? It can be explained. See, one single bond is formed by two electrons. See, CH3, CH, H. Why do we put double bond? That I'll make it clear. See, one this stick or one bond means 2 electrons. So what we can do, remove this bond and here there are 2 electrons, so 1 electron will stay here, 1 will go with hydrogen, 1 will go with this oxygen and 1 electron will stay. So these 2 electrons now combine or contribute to form another bond or double bond. See, CH3, C double bond, CH2 and H. And these 2 electrons will combine and form H2O, that is water. So this will combine, these 2 electrons will combine and a bond will be formed. So this is the logical way of understanding how the double bond is formed. Okay. So next we'll take another compound, ethanoic acid. Let's see the properties of ethanoic acid. See, ethanoic acid is commonly called acetic acid and it belongs to group of acids called carboxylic acid. So carboxylic acids have common or the general formula R C O O H. See, this group of compounds are called carboxylic acids. See, if R is replaced by H, it is see, if R is equal to H, then we get methanoic acid. So this is the way you write the formula. Methanoic, having 1 carbon. And if in place of R, you have an alkyl group like CH3, C2H5, so you get various carboxylic acids. So if R is replaced by CH3, COOH, now it is 2 carbon compound and it is called ethanoic acid. Ethanoic acid. So you must remember the general formula of carboxylic acid. If you remember this, you can write any carboxylic acid. If it is asked that write a carboxylic acid containing 4 carbon, so question is generally asked in the manner. So you can always write. See, if the question is you have to write a carboxylic acid containing 4 carbon. So you already have 1 carbon. So this alkyl part will contain 3 carbon. So the R will be, so your R will be C3H7. C3H7. And the general formula for the alkyl group is CnH2n plus 1, or the easy way is remove 1 hydrogen from the alkane, you get alkyl. So carboxylic acid with 4 carbon will be C3H7 COOH. So this will be butyric acid, 3 and 1, 4. So in this manner you write the formulas. Okay, 5 to 8% solution of acetic acid is called vinegar. So these are few of the important key points that you must remember that will be asked in assertion reason type. That 5 to 8% solution of acetic acid in water is called vinegar and it is used for preservation of pickles. Melting point of pure ethanoic acid is 290 Kelvin. 290 Kelvin. So the best way is to remember it in degrees Celsius. It is 17 degree Celsius. Hence the pure acetic acid will solidify. See, hence it often freezes during winter in cold climates. This gives it name the glacial acetic acid. So pure ethanoic acid has melting point 17 degree Celsius. So it's obvious that in very cold climate it will solidify and hence its name is glacial acetic acid. So this question is also asked in assertion reason type questions that acetic acid, pure acetic acid is called glacial acetic acid. Give reason or the reason may be given that its melting point is 290 Kelvin. So instead of 290 you remember 17 degree Celsius. See, the group of organic compounds called carboxylic acids are characterized by acidic nature. So acid word here it is suggesting it is obviously so acidic character. It will turn blue litmus red. However, unlike mineral acids, which are completely ionized, carboxylic acids are weak acid. What does this statement basically mean? Let's see. See, this point that organic acids are weaker than mineral acids. So if we compare ethanoic acid CH3COOH. So if you are comparing acidic nature means how much H positive ions are generated. So if we are comparing ethanoic acid with a mineral acid like HCl, so you must remember this is a weak acid. Reason being, it will give CH3COO negative acetate ion plus H positive ion, and if we write dissociation or ionization of HCl, it gives us H positive plus Cl negative. See, the arrow that is put is different. In case of acetic acid, it is reversible reaction. So the arrows are half-headed arrow in both the direction. This shows partial ionization. Ionization means it is not completely, if the reaction is moving in right direction, so it is combining and also forming an ionized acid. So this kind of reaction suggests that it is partially ionized. Partially ionized. So acidic nature means how much H positive ions are generated. So the H positive ions are generated and they are also combining with the acetate ion to form unionized acid. Where in case of HCl, it is completely ionized. Completely ionized. That is, the reaction is proceeding towards the right direction. So here we are putting single arrow and in the right direction. No backward reaction is taking place. So whatever H positive ions are generated are contributing to the acidity of the acidity or acidic nature of HCl. So here we say it is 100% ionized, but here it is partially ionized. You can understand in the manner that if you have 100 rupees in a pocket and somebody is asking for the 400 rupees, so whatever you are having 100 rupees, you are lending full amount, but chances are there's one more situation that you may keep some money and lend some amount of money, like you are lending just 20 rupees, keeping 80 rupees with you. So this is the case with the ethanoic acid. It does not give away its whole of the H positive ions. It takes back something. See, some of the H positive combines to form the unionized. So these unionized acid are not contributing to the acidic nature. It is this H positive that is contributing. So it is not lending its whole of the H positive and it is retaining some of its H positive. Hence, it is less acidic than the mineral acids. So this, if the acidic nature is asked, so you can write the reaction and also mention these, make a note of these arrow. This is for partial ionization, that the reaction is moving in both the direction. Here complete ionization, hence the reaction is moving fully towards the right side. Now let's come to the chemical reaction. Reaction of ethanoic acid with alcohol. This is called esterification. Okay. Now let's see what is an ester. See. Now first let's understand this reaction. See, ethanoic acid reacting with ethanol gives ester plus water, and this reaction is taking place in acidic medium. See, esterification, CH3 COOH, then ethanol, this you can write the equation in this manner so that you can remember. So H of alcohol and OH of acid will combine. The reaction takes place in the presence of acid. So water is eliminated and you get an ester. See, CH3 COO C2H5, and this CO is called ester linkage. So the compound is ester and this CO bond in the straight chain is called ester linkage. How you are going to name the ester, that we will see in a while. Now esters are sweet smelling substances and they are often used in making perfumes and flavoring agent. So this is very important point. This is generally asked in exam. There is a compound X is given, it is sweet smelling, used as a perfume and flavoring agent. So identify the compound. So the compound is ester. So in this way the question is often asked to identify the compound. Okay. See, now how you are going to name the compound. See, this part of the ester, see, this part of the ester is coming from alcohol and this part is coming from acid. So while naming the ester, you will first name the alcohol part by using the word alkyl. So here we will use the word alkyl, and to name the acid, so this alkyl part will be named first, followed by the acid part. This will be named second, and the acid part, the ic is replaced by ate. So this is ethanoic acid. So the name will be ethanoic. So you replace this ic word and replace it with ate. So the name will be, see, this alkyl part of the alcohol is ethyl. So you will name it as ethyl ethanoate. Ethanoate. ATE. This is where you name the esters. First, you name the alkyl part, which is derived from the alcohol, and the acid part that will come, that will be the next part of the naming, and the ic of the acid is replaced by ATE. So, we'll take few more examples so that you are familiar and confident in writing the name of ester. See, let's take few of the examples. Okay, so the given compound is CH3, CH3, CH2, O, then C double bond O, then you have CH2, CH2, CH, CH3, CH2, CH3. See, a compound like this is given. So first recognize the part that is coming from the alcohol, this part. So this much part is contributed by alcohol, and the acid part, this much part is contributed by the acid part. So how you are going to number it? See, in this case, let's find the longest carbon chain. So we start numbering from this carbon end. See, 1, 2, 3, 4 and 5, or we can do 4, 5 and 6. So this is the 6 carbon chain acid part. That is, it is hexanoic acid. Okay, and at the fourth position there is a methyl group also attached, and here the alcohol part is ethyl. So what we will write, ethyl, first mention the alcohol part, ethyl, then 4-methyl hexanoic acid. So hexanoic you remove ic with 8, hexonic. So ethyl 4-methyl hexonate. This is the way you write the ester, name of ester. So this is a ester and this is ester linkage. This CO bond is ester linkage. Ester linkage. Why it is so important to recognize the ester linkage? Because the next equation, that is saponification, there you have to identify the ester linkage. See, on treating with sodium hydroxide, which is an alkali, ester gets converted into alcohol and sodium salt of carboxylic acid. This reaction is known as saponification. So first is esterification in presence of acid, and then hydrolysis of ester in presence of base is saponification. So let's understand what is saponification. Saponification. Okay. See, simple definition is alkali alkaline hydrolysis of ester is called saponification because it gives you ester is called see from where we got the word saponification. Sapon means soap. See, it's a Latin word, maybe Latin or Greek. You check it. It means soap. That is, during this reaction, soap is being formed. See, ester plus base, that is NaOH or any alkaline substance you add. So what you get? Soap plus alcohol. So let's see the reaction. See, this is the reaction where ester is treated with a base. So the ester is, see, CH3 COO C2H5 when treated with a base NaOH. So this linkage or the ester linkage breaks and we get alcohol C2H5OH plus sodium salt of acetic acid COONA. So we do not get free acid, we get sodium salt of sodium salt of the carboxylic acid. Here we are getting alcohol. So the logic is that we should also get free carboxylic acid. But since the reaction is taking place in basic medium, we get salt of carboxylic acid. Salt of carboxylic acid. In this case, we have sodium acetate. So the reaction is called saponification. And what is soap? Soap is basically sodium salt of higher fatty acids. So I'll write it down. See, what is soap? Soap is sodium salt of higher fatty acids. Higher fatty acid, or you can say higher carboxylic acid. See, for example, C17H35 COONA. It is sodium stearate. Sodium stearate. Carboxylic acid is stearic acid, and this is called soap. So sodium salt of higher fatty acid or higher carboxylic acids are called soap, and what we are getting here is soap. Instead, see, instead of see, in here we are getting sodium salt of carboxylic acid or sodium salt of acetic acid. Instead of acetic acid, you take stearic acid, C17H35COOH. So that will be stearic acid. So you will automatically get soap. Hence, the reaction is known as saponification. Okay, next reaction is with a base. So reaction with base is easy to understand as it is it's an acid, so it will obviously react with a base. And we already know from our lower classes that acid-base reaction is called neutralization. So basically, this reaction is neutralization reaction. So this reaction with the base is a neutralization reaction. Let's see. Acetic acid reacting with CH3 plus NaOH. So what we are having? We are having an acid and a base, and it will give salt in water. So you get sodium salt of acetic acid CH3COONA plus water. This is salt. So this is basically a neutralization reaction, so it is easy to remember. Neutralization reaction. Let's see another reaction with carbonates and hydrogen carbonates. Hydrogen carbonates are also known as bicarbonates. See. See, reaction with carbonates and bicarbonates, this is also used as a test to identify carboxylic acid or acetic acid. So this reaction is basically used as a test. So you also mentioned this in your notes that it is used as a test for carboxylic acid. See, here in this case, what happens? See, acetic acid, CH3COOH reacts with sodium carbonate, Na2CO3. See, what are the products that you get? Sodium acetate, CH3COONA plus water, and since it is a carbonate salt, so obviously carbon dioxide will always be evolved. So carbonate salts when treated with acid will always give out carbon dioxide. So this is the uniqueness of the carbonate salts. See, now you can balance the reaction. See here 2 sodium, so you write here 2. And since the acetate part is also doubled, so write it 2. Now the reaction is balanced. Now see how we write the reaction with sodium bicarbonate. See, CH3COOH plus sodium NaHCO3. So HCO3 is hydrogen carbonate. it's CO3 negative. So its valency is 1 having negative charge. So you must remember this as hydrogen carbonate or bicarbonate. Okay. So it will react. See, CH3 you get sodium acetate, ONA, plus water plus carbon dioxide. See, the reaction is balanced. Acetate part is balanced, one sodium atom, then two hydrogen and CO2. So the reaction is balanced. So you need to balance only in this first case, that is with sodium carbonate. So this finishes the properties of ethanoic acid. Now let's see the in-text question. How would you distinguish experimentally between alcohol and carboxylic acid? So you have to write this reaction with carbonate and bicarbonate. You can write any one reaction that when sodium carbonate is added to the compound, we obtain this gas, carbon dioxide, which turns lime water milky. So the compound is carboxylic acid. While alcohol will not show reaction with sodium carbonate or sodium bicarbonate. So since it has been asked that you have to distinguish experimentally, so you have to give this reaction. One more distinguishing point is that carboxylic acid will turn blue litmus red, that is it will show litmus test, while alcohol will not show litmus test. So this is another distinguishing feature between the two. So you must remember that if it is asked that you have to write give difference experimentally, then you have to write this reaction. What are oxidizing agents? This we have already discussed, that oxidizing agents are those which add oxygen to the reactant or the substrate to which it is added. And two oxidizing agents that we have already studied are alkaline KMnO4, that is alkaline potassium permanganate, and acidified potassium dichromate K2Cr2O7. Hope you understood the topic well. Please like, share and subscribe. Keep practicing. Best of luck for your board exams. Thank you so much.